Hey guys, welcome back to my channel. Today is the day 33 of Algorithm Challenge, and we are going towards the end of Greedy chapter. Yesterday we briefly but concisely explained what a greedy algorithms were. It's not a data structure, but it's those algorithms that find the local and optimal um, points at every step. Mm, and it sometimes is not that accurate, so a bit inappropriate for Leetcode type of questions where you need an absolutely accurate question answers. But in real life, it's commonly used because at the expense of small accuracy, you can have a lot of a lot of improvement in time complexity. So let me share my screen, and I brought two questions today from Leetcode that we're gonna solve together. No, I was looking at Olympics. But anyways, first one is got to delete it. We got the maximum 6-9 number. So it's an easy level difficulty, and I was able to solve it within 10 minutes. Not 10 minutes, 20 minutes. But yeah, it was impossible to imagine me doing this when I first started the challenge, but I think it's doing its job, doing solving questions constantly, and I'm quite happy with it. But let's get into it. So you're given a positive integer num consisting only of digits 6 and 9, and we have to return the maximum number we can get by changing at most one digit. So the okay, if you see the test case one, num is 9669 and the output is 9969 because the first digit that you can change in order to make it the maximum number is the second digit. But if you think about it, when you traverse from the start till the end, what is the maximum level of maximum? So this is greedy because you can only change one step, and at that one step, you have to get the most optimal solution. So when you're traversing from start to end, the maximum efficiency that you can get from changing it is um, the first number that you're going to see, right? So the highest uh, digit. So for instance, if this was 6966, if you traverse from the start to the end, obviously the first digit, if you change it to 9, then it will become 9966 compared to changing third digits, which becomes 6996. So that is obviously smaller. So it is always better to change the digit, first six digit that you see. So the first uh, always best to change the first digit 6 you encounter. And you will do that by traversing this number. And how are you going to do this? Um, because this num is in 9669, it's not a list, it's not an iterable. So we have to make it into an iterable uh, and something mutable that we can change it and we can also traverse it through, right? So in that case, we would have to make it into a list of strings. So um, num list would equal to list of strings of this num. And now we can traverse it, and for the digit that for the first 6 digit that we see, we can change it to 9, and then return the output. So for I in range length of num list, um, if this digit is 6, so if num list I equals to 6 because it's a strings at the moment. Then num list I is 9, right? Num is 6. And then we break it. Num list I is 6. Then we change it to 9, and then we break the loop. So the first 6 digit that we see, we change it to 9 and we break the loop. And then after that, we return the integer version again. And then we join the strings together to make it into a complete string. So let's see if this works. Syntax. Ah. Mm-hmm. Here a small. Yes, so this works. We just change it to 9969. Do the same for case 2. The last digit that you see is 6, so we change it to 9. So that was pretty easy. We just find the locally optimal solution. Now let's move on to the next example, which is Leetcode 1338, reduce array size to half. So basically you are given an integer array R, and you can choose a set of integers and remove all the occurrences of this integer in the array. You return the minimum size of the set so that at least half of the integers are there in the array are removed. If you see the test case 1, choosing 3 and 7 will make the new array 55522, which is size 5, and the original size of the array is 10. So it's half of the size of the old array. So this means that at least half of the integers of the array are removed. So in this case, the output is 2. Because if you just remove one, one set, then it will still have the length of 6. So how are we going to approach this? We're going to use the greedy approach as well. What we need is to count the frequency of the of each integer, right? So we would need to use the dictionary to count. Maybe you can use the counter function from Python, and we're going to sort. We're going to sort the frequencies in descending order. This is to extract the frequencies and sort them in a descending order and help them in removing the integers with the highest frequencies first. So that is like the greedy part of our solution. By removing the highest frequency integer from the descending order hash map, the dictionary, I mean. Yeah, frequency order and remove integers until half the array is removed, right? Because we have to stop at the point where the half array is removed. And we count the minimum number of sets, and we do this by keeping count of the how many different integers you have removed to achieve this. So let's start. Like we said, we count the frequency of, so step 1, count the frequency of each integer, and that will be done by set. Oh no. frequency equals to counter array. And then we're going to sort this frequency. And that's done by frequencies sorted frequency dot values, because we are sorting the values of that frequency dictionary. And then because it's in descending order, so I think it was reverse equals true, right? Okay, because now we have to go through this integer and then remove it until the integer is, the length of the array is at least half. So remove integers until we have removed half of the array. So that will be done by n equals length of array and half size equals n divided by 2. And current, we define current size as n and number of sets as 0, so that we keep the count of the sets that we encounter while traversing. So for frequency and frequencies dictionary, we have to deduct the number of frequencies and frequencies from frequencies dictionary from the current size. So current size minus the frequency. And at the same time, we keep the count of the sets. So num sets plus 1. And now if it's lesser than the half of the size, so it means that we have reached the half of the integers of the array are removed condition. So current size is half size. Then we break the loop, and then we return the number of size, right? So let's see if this works. Oh, not number of number of sets, I mean. Come on. Yes. Okay. Yes. So idea is pretty simple. You just break down into to each steps, and I guess there's lots of sorting used in greedy algorithms to allow us to find the most optimal solution at that point. Yeah, I guess that was it. I would say we need way more examples to master this. But as for now, we're going to leave it like this. And as we discussed in the previous days, we're going to come back and then, yeah, do more exercises. Tomorrow, we're going to go into binary search. And this is the part that I'm most excited with, because I first made up my mind to do algorithms by looking at some guy's binary search template, and that seemed really efficient. So yeah, I'm pretty excited. And thank you guys again for watching. And if you guys have any comments, leave it in the comment section down below. And yeah, see you guys tomorrow.